In this video, we're going to learn about factors and prime factorization. So if you have whole numbers that are multiplied to find a product, those are called factors of that product. So what that really means is that a number is divisible by its factors. So in other words, if we're talking about 6, the number 6, 2 and 3 are factors of 6 because 2 times 3 is equal to 6. Along the other hand, 6 is divisible by 3, which is 2, and it's also divisible by 2, which is 3. So 6 is divisible by both 3 and 2. When the pairs of factors begin to repeat, then you found all the factors of the number that you're factoring. So we want to list, the first example, we want to list all the factors of the number 16, okay? So we write 16. If we say we know that 1 times 16 is 16, 2 times 8 is 16, 3 doesn't go into 16, 4 times 4 is 16, and you notice that the 4s repeat, so we know that there isn't anything higher than that, okay, because the next one up would be 8, okay? So the factors of 16 are 1, 2, 4, 8, and 16. Now we want to find all the factors of the number 19, okay? Well, so we start off 1 times 19, and then that's it, okay? So the only factors of 19 are 1 and 19. What that means is that 19 is a prime number. All right, prime numbers are numbers that the only factor are 1 and that number. So that would be like 3, well, 1, 3, 5, 7, 11, 13, 14, 15, 16, 17, 19, and on so on and so forth. There's quite a few, but these are the first several, okay? So 19, the only factors of 19 are 1 and 19, okay? Now we want to list all the factors of the number 12, okay? So we're going to say 1 times 12, 2 times 6, 3 times 4, and then 4 would be times 3, but we've already got that up here, right here, okay? So the factors are 1, 2, 3, 4, 6, and 12, all right? Now, you can also use exponents to write prime factorizations, all right? So that's writing the factorizations in using only prime numbers, all right? In the way that we've been doing it, we have numbers that are composite numbers, which means that they have more than 2 factors, okay? Remember that an exponent is a little number up in the corner that tells you how many times that the base is a factor, or how many times you multiply that base times itself. To do prime factorization, we use what is called a factor tree, okay? And that just simply, oops, we're not doing 12, we're doing 24. Okay, so that just simply we say, well, 24, we can say that's 4 times 6. You don't have to do 4 and 6. You could do 2 and 12 or 3 and 8 or something like that. Okay, but I did 4 and 6. Okay, well, 4, you can break 4 down into 2 times 2. Okay, you can break 6 down into 2 times 3. Then, and this multiplication sign here just comes straight down. Okay, now 2 cannot be broken up into any other factor, so twos are prime factors. Okay, so we have 2's and 3's are prime factors. So we end up having 2 times 2 times 2 times 3. So the bases are 2 times 3. And we multiply 2 times itself 3 times. So that would be 2 to the third power times 3 to the 1 power, because there's only 1 3. But if there's a 1 power, you don't write it down. Okay? So the prime factorization would be 2 to the third power times 3. Let's do the prime factorization of 45. All right? So we know that is 9 times 5. All right? 9 can be broken down into 3 times 3. Okay, bring that multiplication to sign down. And 5 is already a prime number, so we just bring it down. All right, so this prime factorization is 3 to the second power times 5. Okay, prime factorization of 28. And the whole thing with doing the factor tree is that you can do numbers that are large, do larger numbers, that it would be really time intensive to just do it in your head as far as knowing what goes into it. But anyway, 28 would be 7 times 4. 7 is a prime number, so we bring it down. 7 times 4 is 2 times 2. And now we have all prime numbers. Now, what we normally do is we put it in order from smallest to largest. So that would be 2 to the second power times 7. Okay, 36. Okay, 36 gets broken down into 6 times 6, which is 2 times 3 on both of them. So we have 2 times 3 times 2 times 3. Well, there again, the bases are 2 times 3. You have 2 2's and 2 3's. So that's the prime factorization of 36. Okay? So if you have any questions, make sure you ask, and we'll see y'all later.